Okay, this is Unit 7. We've got a couple of pieces to work through here, the first one of which is web architectures, and this is going to give us a context so that the code you're going to write, the project you're going to do, actually makes some sense. Okay, and it's a good piece to understand because it'll really affect what you try to do, where you try to put things. The idea we talked about back in Unit 5 of we have all these devices and they cooperate, that's fine. But somewhere to support that, we need some plumbing. And this is going to talk about one key piece of that plumbing, which is from an application perspective, how the internet works. Obviously not in too much detail. We're not going to spend weeks on it. But here's the web, the big picture. So what's different about web applications than normal applications? For instance, the application you did in Unit 6, I think it was, where we did the drag and drop GUI, that produced a single program that ran on a single computer, and it was all together, and you had access to everything. What we do with web applications is we take the application and we chop it down the middle into two pieces, traditionally called the front end and the back end. And we take those two pieces and we put them on different sides of the internet. So for the front end to talk to the back end or vice versa, it's got to go through the internet, and that means we have to drop a network stack and a protocol and everything else in there. And this changes fairly dramatically how things actually work, although if we work hard enough, we can make it look a lot like the internet isn't in the middle of all these pieces, that they're all actually together into one big program. That's a tricky process. So when we chop it into these two pieces, what ends up happening is on the front end, what we want to do is we want to have it work in the browser, okay? There was a period where we would chop applications into two pieces, a front end and a back end. It was called a client-server model. And we would have most of the program in the front end written in some conventional language, and it would run, and it would do some custom talking to the back end. And the problem with that is that if you had a bug in your code, and there's always a bug in your code, you would have to send the user a new program, and you would have to get them to load it. And for a while, the internet was slow enough. I remember when there were 2400 baud modems, that typically that meant you were mailing them CDs. And we went through a period where people were using CDs they had gotten like coasters after they loaded software with them. People would just have stacks. I don't mean people that were into being programmers or IT people or anything like that. I mean just random people would end up with just stacks of DVD with software that they treat as coasters, or they'd make them into wall hangings or something. There's this problem of how to get rid of them. And getting them to load them was some effort too. So a local bank, maybe they have some program, they want you to do your banking with them online. They think that'll be a great benefit to lock you into them instead of some bank down the street. Okay, fine. So they send you their software because it's all custom, and they send you a CD and you gotta load the CD. Well, great. Then a week later they have a bug, so they send you another CD. Well, what happens between the time that the bug happens and they ship it and when you load the CD? Well, they've got to support both versions of the program, right? And that's a real pain. So what we've gone to instead is the front end, the end that's on the user device. It's all in a browser. And the browser knows how to display the HTML, and it knows how to run JavaScript, and we'll come back to this point over and over. The back end has a web server on it, which can run a number of languages, maybe PHP, for example. But the bottom line is the back end comes up with HTML, possibly with some JavaScript and CSS, and it sends it over the internet. Now, the nice thing about this is that when we find a bug in our code, okay, so the browser people we assume can take care of themselves, and browsers have gotten pretty bright about updating themselves, and that we assume that that's not our problem. We assume that our user will have some browser, maybe it's Chrome, maybe it's Edge, maybe it's Internet Explorer, maybe it's Firefox, but they'll have some browser, and it will take care of itself, and it won't just be for us, which means that the user has a lot of incentive to let it update itself. but we're not going to worry about that. So the bugs we care about all take place on the back end in our data center where we have control. If we find a bug and we fix it, we tell the operations staff who we pay their paychecks to, hey, you need to install this. And because they're getting paid, they'll install it. And the next time you hit the website, you'll have the bug fix. And so this is a huge advantage in business model. So let's look at how this works in production just a little more granularly, a little more in detail. And let's start with this. This is a 3-tier architecture. This has become the standard way to think about network applications. Now, actually, we can generalize this a little bit into something called an N-tier architecture. We'll start with the 3-tier architecture. And so we have a user device, right? User device over here. This is likely to be a PC or a Mac. It might be a tablet like an iPad. It might be a smartphone. It might be an iPhone. It might be an Android. It might be a number of other things. But it's some kind of a user device that, and the key point to it is it knows how to talk to the internet, and it knows how to display web pages, right? It talks over the internet, so it can be anywhere in the world, to some application servers. They're typically in a big data center. They talk to these application servers using standard internet protocols. And we'll see in a minute what runs on the application server. Guess what? It's applications. And then those in turn talk over a network. And that network is typically a LAN, a local area network that's in the data center to a database server. Okay. Although this could be back out over the internet to a different data center, but most likely and most typically, the application server and the database server are in the same building. It's a data center. It's a big data center. It may have tens of thousands of computers in it. Big data center. And they run on separate computers, CPUs, but they talk to each other over a local area network. But we've generalized things to the point where if these are in 2 different buildings, 2 different data centers connected by the internet, everything will still work. But typically they're in the same data center. But you'll notice we've broken our application now that used to be just one process. We've broken it so that it runs on 3 different pieces of hardware. Part of it runs on the user device. That takes care of displaying stuff to the user, and it takes care of getting user input from them. There's the application server, which has the logic for our application, what it does, like maybe it's a banking application. And then we've got a third set of hardware, which stores the data. Almost always a database server, very typically. So we've taken our one application, we've broken it across 3 pieces of hardware. We've connected our pieces of hardware with networks. That's the 3-tier architecture. Now, in theory, we can break our application up into even more pieces. Maybe instead of having one application piece running on one server, we've broken that into more pieces. They run on more servers. That becomes what we call an N-tier architecture. But key parts are those N-tier architectures. They still have the front end, the part that interacts with the user on a user device that's on the other side of the internet almost always. These may well be in the same data center, even we break into pieces. And then we have some other tier that stores data, usually by using a database. And so that's our 3-tier, our N-tier architecture. We'll drill down a little bit more. So the user device, the key point to the user device is it has a web browser, okay? And that's a standardized piece of software. You don't get a different display piece for each bank you do business with or each department store you have a credit card with or anything like that. You have a browser and you use it for all sorts of things. You look at news on it, you order from Amazon on it, you do online banking with it. It goes on and on. It's a stock piece. It might be Chrome, might be Firefox, might be Edge, doesn't matter. All of those are similar enough that we don't have to worry too much about which one we have. We throw them the same stuff and they figure out how to display it. And the stuff we count on every browser knowing how to handle is HTML, which I think you've seen a lot of, CSS, cascading style sheets, which provide some style and some appearance to HTML, and JavaScript. All the standard browsers all know how to actually execute JavaScript programs, and these JavaScript programs in turn know how to read and modify the HTML. And all that takes place in the browser on the user device. We flip it out there to you when you hit a new page. We flip it out there to you, but once it's out there, it is running independently of the web. So I could flip a new page out there, unplug the web, I would still have access to it. Okay. So our browser talks over the internet, and it talks over the internet using a protocol called HTTP, and HTTP is designed to move around blocks of HTML, CSS, and JavaScript, and this part's all standard, so it works regardless of the browser on the one side, and it works regardless of the web server on the other side. Okay, we've standardized this piece. Then over here in the application server, we can have application programs, but the key piece is we have a web server. And we'll talk more about web servers in some detail. So web servers basically either read a page off a disk. If it's a static page, like you probably learned, you probably typed in a little page of HTML. It'll pick one of those up and flip it across the internet. But also most web pages now are dynamic. We have programs that build web pages for us, and then after the web page is built, the web server tosses it off to the user device. Okay. With the three-tier model, which is typical, three-tier or n-tier model, which is typical, then those application programs need to read and write data. They do that across another network. It's often a data center LAN network. It could be another hop out to the internet. They talk to database servers. As you might guess, they typically run database programs. There are a couple of different choices there. Most of them are SQL. In general, our database server uses SQL. Yes, that's starting to change a little bit. There are starting to be some other alternatives, but let's keep it simple for the moment. And actually what we communicate over the network here is actually SQL as well. We put a little thin wrapper around SQL that the database server knows how to strip off, and our application program generates SQL and puts a little wrapper around it when it goes down to the network. That gets to the database server. We strip the little wrapper off and we run the SQL. Okay. Well, let's talk more about the web server. So, reminder that the web server is talking to a user device using HTTP, HTML, CSS, JavaScript, right? So the only thing the user device sees is these protocols here. The user device has no idea what language you're using over here on the application server. The application server ultimately builds a web page. The web page that builds has to be in standard HTML, CSS, JavaScript, and then flips it over. There was a period where people tried to make some effort to match special features in their browser to special features in their web server. Microsoft was most aggressive about that. Surprise, surprise, surprise. And what ends up happening is if you don't use the right browser, you can't use the website. Okay. I went through this with my wife. We had an infant child. I was trying to do a PhD. She was doing one of these sale at home thing, do sales things. Happened to be Southern Living at Home. And she would sell some stuff and she'd get an order and she'd need to put it into the website to record that. And the problem was they had built their website using Microsoft Tools and Microsoft Web Server. And I had a Mac, and they had stopped having a version of Internet Explorer that would run on the Mac. I could run Firefox on the Mac, but the Firefox didn't support the features that Microsoft added because Microsoft made them proprietary and would have sued Firefox if they had added the features. And so other than trashing my Mac and buying a Windows box so that I would then be buying more Microsoft software, there's no way for my wife to put that in. And her end solution was she would go down to the college library where I was doing my PhD, and I would babysit our infant and try to do my schoolwork. I found it hard on me. I'm real into standards now. So keep that in the back of your mind. No matter what we do on these application servers, what we have to end up with to talk to a browser, because we don't have control over which browser people pick, are these things here: HTTP, HTML, CSS, JavaScript. Now, our web server, we can do all sorts of crazy things to generate web pages, but most cases, different web servers know how to deal with different languages. Okay, we'll talk in a little more detail about this. Common languages to use on your web server, well, common may not be the right word. PHP is common, ASP is sort of common, JSP is out there, and then there's CGI. Now, these first three, what's interesting about them is that our web server, from the operating system perspective, our web server is a process, right? So when we start up the web server, the operating system starts a process up. That takes a little while. If you've launched something like Microsoft Word, you get a feel for, oh yeah, there's some effort here in cranking this thing up. You know, it's a program, all sorts of things have to happen. When you take an operating system course, they might explain to you all the things that the operating system has to do to turn a program into a running process. There's a lot of work, and it takes a while. Okay, but the web server, once we crank it up, we leave it up for days, weeks, maybe months, right? And so if it's well written, doesn't have memory leak, stuff like that, it can just run along for a lengthy period of time. Doesn't really matter that it took a while to get up. You know, it's handling, as long as it's handling its web request very quickly. So it gets a web request to run some program. Now, these languages here, PHP, ASP, JSP, what it does is they actually run as part of the same process as the web server. There's not a separate process. It's part of the same process. And that means usually it forks a thread up for them, but threads are much quicker to come up. That means using these languages are quick. When we get a request for a dynamic web page, which is most web pages now, that very quickly does it. So for instance, when you try to look up your grade, from Purdue Global, you hit some web page with it. We don't have guys in the back room that go, oh yeah, Tom wants to see his grades. Let's look those up and start typing up an HTML page. No, we have a program that reads the data out of a database and writes up and formats up an HTML page and flips it back across the internet for Tom to see his grades. Okay. So I mentioned there, the last thing I mentioned is CGI. CGI is Common Gateway Interface, and this is a standard interface between a web server and another program. Another program, not part of the web server, another program. This other program can be written in almost any language. The first shot I had doing stuff on the web, we used CGI and we wrote in Java. I've also written in C++. Or was it C++ that I started with? Trying to remember. At any rate, you can write a program in almost any language. The problem is this other program, this program you write, is run as a separate process from the web server. Okay, the web server, it gets this request for a page and it realizes that it's supposed to use another program for it that knows CGI, and it will do an operating system call to run the other program. But that means it takes a while for that to all get kicked up and running. So this means that we have a new process is started for each page request. Each time someone requests a page, we have to kick up another process. This is very, very slow. You don't want to do this. Oftentimes in the web, I've been looking around, they'll see it where they say, oh yeah, this web server will handle any language. Well, it's true if you use CGI, but that's too slow. The question is, what can your web server do without starting another process? And that turns out to be rather limited to certain things. Now, just because it doesn't fit anywhere else, I'll mention another thing. You may have heard of Node.js. Node.js is a special web server that's written in JavaScript. Now, we kept saying JavaScript and browser, JavaScript and browsers, and browsers know how to execute JavaScript. Well, they produced a runtime for Java that's independent of a browser, and that means that you can run JavaScript programs without browsers. And specifically in the case of Node.js, you can run JavaScript programs as servers. So Node.js runs on the application server, not in the browser. Node.js talks to the browser using HTTP. The browser never realizes it's talking to Node.js. It just knows it's talking to a server that knows how to speak HTTP. Okay? To use Node.js, the programmer modifies the Node.js web server code for a particular application. Okay? So they customize it to do a particular application. If we're a bank, we customize it to do online banking for our bank or whatever. Now, this can be extremely efficient, right? Because it's all customized for what we care about. and that can work just great. But it means we give up the generality of a web server. Okay, it's only doing one kind of a thing. But just keep that in the back of your head. Now it runs on the server. It's an example of server-side JavaScript. Okay, so having said that, let's talk a little bit about the web server market share. Okay, you see the URL down there of where I found this just recently. This is for 2019. You can see Apache 43%. For a long time, Apache was over 80%, but this other web server, I don't know how to pronounce this, NGINX, that's another open source server. It was designed to compete with Apache, and the two of them have sort of split up that 80% of the market share. So Apache is open source. You can download the source code if you want, and you can mess around with it. It supports within the same process PHP. That's one reason PHP is so popular. Python, Perl, and CGIs. And there's probably something else I didn't find during my research. But basically, if you want to use Apache in general, you probably want to use PHP. If not, you probably want to use Python. Perl's getting to be rather long in the tooth and old. People are getting away from Perl. Okay. This NGINX, I don't know how to pronounce it, is also open source. It was designed to replace Apache. It's 4 times as fast as Apache. It was designed for use in the cloud. It's normally used in something called a Docker, which is a way of being modular with your cloud software. It supports PHP, Python, Perl, and CGI. Notice it's supporting the same stuff. The idea is if you've been using Apache, they want to make it really easy to switch over to this. As it's open source, you can once again download the source, build it yourself. You can get a free download. You're like, what's the business model on these? Well, Apache is run by a foundation. People donate money. There's a nonprofit foundation that keeps Apache going. This NGINX, that's was written by a for-profit company. What they did is they put the software on. What they do is they charge if you want help with it. You know, if you need help configuring it or you want some nice documentation, you want some modifications, you're not sure how to configure it, you pay them. Okay, so that's their business model. This 2S is from Microsoft. Microsoft 2S, that's another web server. It's a Microsoft-specific web server. Apache and NGINX you can run under Linux. You can run them on Windows. You can run them on Macs. 2S from Microsoft, you got to run on Windows. They've intertwined it. Microsoft likes intertwining their software, so to use one thing from Microsoft, you have to use everything from Microsoft. This web server is yet another example of that. Okay, so you pay Microsoft to be able to get a license for 2S, and then it comes with some support. Unlike since NGINX is doing that, except you can have it and just opt out of their support. You can get your support from other people, figure it out yourself, whatever. So 2S from Microsoft. It supports ASP. ASP is a Microsoft language that was designed to compete with PHP. It supports Python, which is an open source language. It supports CGI, so in theory you can do anything with it. But of course, bringing those processes up to use CGI is expensive. Then there's Tomcat. Tomcat was originally written by Sun. It was taken over by the Apache Foundation, but it's not the Apache web server. Its main claim to fame in life is it was written in Java and it supports JSP. Okay, when you see in a little bit that makes sense because JSP is basically a way of sticking Java into a web page. So if you're going to support JSP, you have to do the work of supporting Java anyhow. Okay, it also supposedly supports PHP. I've never seen it used that way. It supports Java, so you can write programs in Java and have them take part in the same process. Unlike like if you do Java from 2S, it's a CGI thing. You bring up a separate process, and they'll do CGI as well. Now you'll notice the Apache and NGINX, between the two of them, they have 85% of the market. Microsoft has 8.5% of the market. You might wonder about that. Then there's some other random things, and we get down to Tomcat is less than 0.5% of the market. Okay, but basically Tomcat's the only thing that's going to support JSP, and so your choices for your project, your choices for your project is if you want to do a Java-related approach, you do JSPs, and if you use JSPs, you need to do Tomcat. And the only good thing about all that is Eclipse is set up to make it easier to work with Tomcat. Now, if you do the Microsoft approach, the C# approach, Visual Studio, like I said, Microsoft likes to entwine things, so they took their web server and they chunked out the parts that you need to do development, and they molded them into Visual Studio. And so it's just a matter of telling Visual Studio, hey, turn on the web server part, and it will turn on this cut down version of 2S so that you can do your ASP development. Do understand that both ASP and JSP, you need to have a web server to end up with a web page that your browser will understand. If you were to somehow try to flip out ASP or JSP and get it into your browser would not know what to do with it. It would probably try to display as text because that just seems like as close as it's going to get. Okay, looking at this, you might say, well, gee, wouldn't it make the most sense to learn PHP with Apache? Yes, it would. That's not really one of your choices, although if you do the web language version, you can do PHP. Presumably by now you've gotten some sort of server set up. It would be nice if they would set up for this course an Apache web server off on some server somewhere where you had an account where you could do it like the real world does, but that's not the world we live in. So that's what the market share looks like, and that's what you can do with what, okay? So a reminder, what does it look like in production? We did this, but I just want to remind you of this for a minute. In production, we have user devices, PCs, tablets, smartphones. They run browsers. The browsers talk over the internet to web servers. The web servers run in some data center on some application server. Okay, there's a network in the middle. That's the whole point to this. If we don't care, if we're not interested in having the internet smack in the middle of our program, it's much easier to write programs that are just GUIs like we did in Unit 6 that all run on one machine as one process. Okay. Now, to do development, there are a number of ways you can do development for this. The approach that we're going to take to development looks like this. We're going to take our user device. We're going to run an IDE, an integrated development environment. That integrated development environment has a cut down browser to it and has a way to work with a local web server. So if you use Eclipse as your IDE, the Eclipse, by the time you configure it for this, will have a little browser thing to it so that when you run your code, you'll have a little extra panel pop up in your IDE, another tab in your editing area, and it will have your final HTML, the page that would go to your a browser normally. It will be right there for you to see. If you use Eclipse, you will need to have that run through. You'll use JSP, and you will need to have that run through Tomcat to do that. Fortunately, there's some configuration that causes Eclipse and Tomcat to get very friendly with each other and pass things back and forth very seamlessly once you get them set up and configured. Now, setting them up and configuring them is a little interesting, and of course there aren't good instructions for it. I'm going to try to provide you some decent instructions. It took me about 12 hours to figure it out, but I did get it. So allocate your time accordingly, okay? Alternately, you can use Visual Studio. You can write, if you use Visual Studio for this project, you'll use ASP. It has some kind of a little browser thing they'll kick things into when you get results back. Visual Studio, as I described, it has a version of the 2S server that's been cut down. It has a chunk of it. The chunk that you need is integrated into Visual Studio. You just have to do a little configuration, a few settings here and there, and you write your ASP, and when you run your ASP, it gets whipped through the cut down 2S, and the results kick back as HTML and show up in a page, a screen in Visual Studio. Okay, you'll notice there's no network on this slide. Okay, so for production, if we didn't have access to a network, this would be really pointless. But for our development purposes, we can do all our development on a single device that doesn't even have to be connected to the internet. And then when we get all done and working, we can worry about doing something with it. Okay, so this is the overview. This is the pieces. So hopefully this will now make sense as you develop code, why we're developing this strange code when it would have been much, much, much easier to just write it as a GUI for a single process. Okay, so keep this in the back of your mind as you work through the assignment for the unit. And we'll see you next week. Actually, I'm going to do another video for you, I hope. That's the plan. So this is first video. Hopefully there'll be another one. There'll be more detail.